So this is logs and exponents, revision questions. Okay, so question 1 was a plus b log 4 to the 7 plus 60 log 8 to the 14. Okay, so initially I'm noticing the bases of the logs are not ideal at the moment because they're two different bases. So my thoughts here was to change them so they are the same base. And perhaps, so we're going to use the change of base rule. So I did a plus b, and I'm going to use e as the base. So it's easy to write ln 7 over ln 4.
You're changing it to 1.
Yeah. Okay. Yeah. ln 8. I don't know, ln 14 over ln 8. 0. Okay, so hopefully you're all okay with that so far. Now ln 4 is, well, that's 2 squared, and that's 2 cubed.
Yes.
So that means I can bring those down in front. So I'm going to do that next. ln 7, so that's going to be 2 ln 2, and that's going to be 3 ln 2. So I'm getting to having something that's a common denominator here. That's why I did that. 3 goes into 60 20 times.
Yes.
And I'm going to multiply everything by ln 2 to get rid of this denominator. So I'm going to get ln a times ln 2 plus, well, that's going to be b over 2 times ln 7. And that's going to be 20 ln 14 equals 0. All right. Still not quite there. If I can form two separate equations in a and b, I can get there. So this was something you there's an ln 2 and ln 7, and what I noticed is that ln 14 can split up into ln 2 and ln 7.
Yes.
And then you have an equation ln 2 and ln 7. Let's look at that. So that can split up. How does that split up, Sean? How would I do that?
It would be ln 20 times ln 2 plus ln 7.
Yes, so using that rule, so ln 2 plus ln 7, 0. And then I can then have these separately, then 20 ln 2 plus 20 ln 7. Now I'm keeping this the same. All right, so if I know all that equals 0.
Oh, and then you can just equate the things in front.
Yeah, so I'm going to factorize out the a plus 2 out of, or a plus 20, a plus 20 out of ln 2, and b over 2 plus 20 out of ln 7. And then if that equals 0, well, a would have to be negative 20, wouldn't it, for this all to work out? And b then would have to be negative 40 for all that to equal 0. See that on your screen. All right, satisfactory, hopefully.
Yeah. Okay. I didn't. What I did instead was I changed it to base. I changed the 8 to base 4 because I thought 8. Oh, I can turn it to 4, and that would have actually worked if I noticed that I could turn the 4 into 2 squared and then. Okay. Yeah.
You didn't necessarily have to use ln e, but I just like it's less writing. But yeah, you could have used 4 as well.
Okay.
Mara, are you okay with that? That was an interesting question.
Yeah, okay.
Okay, so yeah, not initially. It looked nicer to start with, and then it kind of didn't quite perhaps work maybe the first time you did it, so that's why I needed a second go at the second question. Perhaps was slightly easier. Tamara, did you get an answer for the second one? Which is the 15 to the 4a. It wasn't easy, it was just easier.
No.
John, did you get an answer here?
I got 2 ln 3 over ln 5.
Okay, let's see if you're right. So once again, I want to find 15 and 81. I don't want them to be 15 and 81. I noticed the way 81 is 3 to the power of 4 anyway. and that's plus 2. Okay, so that's usually a good thing to get it down into its lowest base. And this is 3 times 5, of course. So that's, I can just write that 3 times 5 like that if you want, and that's to the 4a as well. Now, are you happy with me writing 3 to the 4a times 5 to the 4a for this?
Yes.
Okay, so hopefully tomorrow you're okay at that as well. And I'm going to kind of split this up the same, because I want a 3 to the 4a. I can see that's going to be 3 to the 4a here. And then it's going to be, so it's going to be 3 to the 4a plus 8. So that will break up the same as this broke up into times 3 to the 8. And then you can, it's like unadding them, I suppose. Or unmultiplying them. All right, and the reason I did that is because this would cancel with this. And that eliminates some of our issues. So we got 5 to the 4a is equal to 3 to the 8. Now I need to get that 4a down on the ground, don't I? So I'm going to have to, what do I do to both sides, Sean?
Ln.
Yeah, so if I do ln both sides, I'm going to get that 4a down to the ground here. Not 5a, just 5. And that's ln 3 to the 8. So once that's down, I can divide then both sides by 5. So that's ln 3 to the 8 divided by ln 5, I suppose. And that 8 can come down here, can't it? So just pop that down. Dividing by 4 will give me 2 ln 3 over ln 5, which is Sean. I don't know if I'm on screen anymore. Okay. Excuse me. All right, so that was question 2. Question 3. How'd this one go, Tamara? Question 3.
I was also confused.
You were confused again? I did notice that I could see how often you access the document, Tamara. So, notice that you haven't looked at it quite very often.
I looked at it on Tuesday because yesterday I had an exam for the unis I was going to. And then, so on Tuesday I looked at it, and then I tried to do as much as I could then. That's why I wasn't accessing it yesterday.
Okay. All right, I was wondering. All right. Anyway, let's have a look. There's the sequence. What's the question? Find the common ratio. Okay, so the ratio. Sean, what'd you get for the ratio here?
2 over 3.
Yeah, so you just put 1 over the other, and you're going to get 2 over 3. So hopefully that makes sense. So u2 divided by u1 will be 2 over 3. So that was pretty much easy marks. Part B then asks for show the sum of the infinite sequence was 9 log 3. Well, I'll do this quite quickly. So the sum of the infinity to infinity, the first term, 3 log 3 to the x, all over 1. Take away. Oh, I didn't research that, did I?
I mean, it makes sense that it's 1 minus that, because otherwise it'd be negative.
Yeah. Right. I didn't research it. No, I forgot. Sorry, I'll get to that. Okay, so that's gonna be 1/3, and then dividing by 1/3, you multiply by 3. So we show that. That's okay. Oh, that was yes. So tomorrow you shouldn't have been confused by that. That should have pretty much been a gimme. Those first 2 parts. Part C, using the first 3 terms of an arithmetic sequence, find the common difference. So that's just subtracting u2 from u1 or u1 from u2. So the difference, the second term is log 3 to the x over 3 minus log 3 to the x. What did you get here, Sean?
I got -1.
Okay, what was your method?
That's going to be log 3 of 1 over 3, because it's x over 3 divided by x, and then that's -1. Did I do that right?
Log 3 of 1 over 3. Sorry, I'm trying to visualize that. Log 3 of 1/3, is it?
Yes.
Where's the x gone?
Because log 3 x over 3 isn't one of the roots.
Sorry, you've combined these two. Yes, sorry. No, I just thought you were converting this one.
No.
Yeah. Not the way I did it, so you can do it that way. I did it I split this up. The same thing. Log, I did 3 to the x minus log 3 to the 3. And there's your minus 1 there. Log,
okay.
3 to the x. Same thing. You just applied it to here, and I just split that up. So that cancels with that, and that gives me minus 1. Log 3 to the 3 is, of course, 1. Okay, so part D then is a show that, so I'll do that, and I presume you were able to do this one, Sean?
Yes.
So the sum...
Right. Yes.
The sum to infinity to u1 plus, so I just used the sum of terms formula, and it's saying that we're looking for the first 6 terms. So S6 is going to be 6 over 2, twice then the first term in that sequence, which was log 3 to the x, and then plus 6 minus 1, of course, 5, and then minus 1, which is the difference we just found. You could tidy all this up. You're going to get 6 over 2, and that's 2 log 3 to the x, and that's minus 5. And then when you apply that, I should have ready. But when you apply that 3 multiplied in, you get what they are asking to show that. Log 6 log 3 to the x minus 15. Okay, and that's what we were asked to show that. Very nice 3 marks there if you got that in the exam. Part E then. Given that S6 given that S6 is equal to 1/3 of the sum, so S6 is equal to 1/3 of the sum to infinity, find x. Sean, what'd you get here for x?
I think I have forgotten to do the 1/3 part of it.
So you didn't multiply by 1/3? Okay, so we have this from the previous one. And 1/3 then, the sum to infinity, minus 15, isn't it? Minus 15 equals, sum to infinity then would be, we had that from earlier, didn't we? Yes, in part B we have the sum to infinity, so that's 1/3 of that, 9 log 3 to the x. Okay, and that's 3. Okay, so that's 6 log 3 to the x minus 15 is equal to 3 then log 3 to the x. So I'm going to bring the 15 over here and then subtract that. So that's going to be 3 log 3 to the x is equal to 15. And dividing by 3, that's going to equal 5. So log 3 to the x is equal to 5. So Tamara, what's x? Oh, sorry. Mara, you there?
Yeah. 3x equals.
Oh, so your camera's gone sideways.
Yeah. And blurry.
Better?
Yep.
Yeah.
Okay. So remember, very simple, log 2 to the 8 is always 3. So can we, that's a simple example, can we apply that here? So x is going to be... That's right, 3 to the 5. Because 2 to the power 3 is 8, so 3 to the power 5 is x.
Oh, yeah, I should have realized my answer was wrong, because I got -5, but it says z, which is in positive integers, right?
Z is...
Wait, no, z is all of them, isn't it?
Yeah, it is all of them, yeah.
Oh, okay.
Could have been right. Give me an answer as a form. But would there be any reason for it to go into the negatives?
Well, if it was 3 times as much as it was meant to be, apparently.
Okay, so that's the answer to that one. All right. Question 4. Show that. All right, Sean, were you able to show that for question 4, the log 16?
Yes.
Okay, so Tamara, I presume this one confused you or you didn't quite get to it? All right. Okay, so I want one to look like the other. I'm going to pick the one on the left to look like the one on the right because I know I can break up 16 into change of base, can't I?
Yeah.
Is that what you did, Sean? Yeah. Okay, so that's going to be log. I'm picking log 4 because I want log 4. Log 4 to the cos 2x plus 7, and that's going to be over log 4 to the 16. So using the change of base rule. 4 to the 16, 4 squared, of course. So that'll be, I'm just going to change that to 4 to the 2.
Yep.
And then that's going to be 1. So then I can just kind of like that. And then, so that's a half. A half log 4 to the cos 2x plus 7. And of course, a half, that's the power here. So that's going to be my square root, which is great. It's going to be the square root of cos 2x.
Yes.
And that's that done for part A. Part B, was that another show? Hence or I solve. What'd you get here, Sean?
I got pi over 6.
Okay, let's see if you're right. Spoiler alert, you are.
Yay.
Log 4 to the, so this is the equation that's given us. Square root 10 cos x. Now it's saying it's equal to the this version, but I'm going to let it equal to the new version straight away from part A. Because it says hence or otherwise, but I presume it's easier if I do it this way. Because I have log 4 on both sides, which is a good start, which means that this equals that.
Yep.
So I'll start with that. I won't rewrite it. I'll just kind of do that.
And now it becomes a trick question.
It does become a trick question, yes. So I'm going to square both sides to get rid of the square roots. 10 cos squared x is equal to 2x. Sorry, I've left out the cos here. Cos 2x plus 7. Cos 2x plus 7. All right. So we've a double here. So I'm going to I'm trying to make quadratic perhaps out of this, maybe, or yeah, something, yeah, with just cos squares and cos. But this will equal cos 2 cos squared, I think, from our identities. We know that plus 7. So that's just cos squareds now. Okay, so that's great. That can be 8 cos squared over here then with the 2. And that's going to be 6. Yep, 6. And then divide by 8. So 3/4. 6 over 8. Am I off screen? It looks like I'm off screen. Yes, sorry. So cos squared x is 3/4. So therefore, square root of both sides, cos x is going to be then root 3 over 2.
Yep.
Okay. And cos, so inverse cos, and that's pi over 6, isn't it?
Yep.
And does that satisfy, did it give any conditions? That
yeah, it says between 0 and pi over 2.
Okay, so that's great. We don't have to go around or anything like that. It's between 0 and pi over 2, there won't be another one. Okay,
Yep.
Sweet. Awesome. All right, that's question 4. A tricky type of logs question. Question 5 is another tricky type of log question, which had log root 3 to the sine x minus log root 3 to the cos x, and that's going to equal 1. Mari there?
Yes.
What would be your first step here? Any ideas what you might try?
Put them together So divide sine x and cos x?
Yep. So log root 3 is going to give us sine x over cos x. That's a great start. And so that's going to be tan x, isn't it? So I'll just add that to tan of x. Better. Tan of x, the log root 3 of tan of x is equal to 1, but perhaps we could change that. So it's also log root 3. So instead of 1, I can write over here log root 3 to root 3 like that.
Yes.
Instead of 1, that would equal 1. So that means that equals that, which is a known angle, of course, isn't it? So saying that, we can say that tan x then equals root 3. Therefore, x is, John?
Pi over 3, right?
Yes.
Yes.
Pi over 3, and I think we have the same conditions between, yeah, we're just looking for the only example between 0 and 90, and that is our answer.
That's quite nice for 6 points.
Very nice for 6 points. I have a feeling that's taken from an SL paper, but it is a HL standard. You mightn't get 6 points. You might only get 5 points for that. But no, you might. I don't know. It looked confusing, so perhaps often when
it's confusing, you'll get more points.
It's probably like a question 1 or 2 in a paper 1, if it was given. I can't remember where I got it. But anyway, so that's the logs and exponents. Let's just cancel that recording so I couldn't paste it.